am Daz. It's been sitting in the loft a long while. I think I was gifted this over a decade ago. It's a Hitachi shortwave adapter to go in a car, model number WM20. I don't know what date it is, but I'm guessing it actually might be 60s, given the amount of chrome and the styling of it. So the basic idea of this device is it sits between the car aerial and a medium wave or AM car radio, and the idea is it acts as a frequency converter, and then the car radio is used as a sort of tunable IF, intermediate frequency, so you can tune stations in. I guess it's a bit cramped because, thinking about it, I don't think any of these bands are more than about 500 kilohertz wide, but so I don't use the full tuning. But it's got 2 transistors, I understand, and yeah, it actually says 2 transistor there. I don't know if that's showing up on the camera, upside down of course. I believe it's in a configuration of a mixer and a separate oscillator. So I guess when this is in the off position, the aerial just goes straight through to the car radio as normal, and then as these are switched, it switches on the unit and does its down conversion. So just looking underneath, yes, it's 6 volt and 12 volt, negative or positive earth. There's a trimmer here marked shortwave trimmer. It's the instruction book, which unfortunately I ain't got. Looks like I'm missing a lot of screws. On the rear, that's the power connection, an aerial plug for the car radio, and a socket to plug the car aerial in. That's probably for earthing, I guess, of the unit. I seem to be missing rather a lot of the screws for the case, so I just wondered if it worked, or whether it needs some work on it. So perhaps I'll whip the lid off so we can see what's inside. Well, here's one cover off, and we can see an electrolytic capacitor there, Nippon Chemicon, 50 microfarad at 15 volts, so it's an older style value at 50 microfarad. Seems to be a chassis mount capacitor here on the input, power input, so that's no doubt to stop the noise coming in. You can see the outgoing aerial cable goes to the off switch, so I guess that's where it's switched. There's another rather large, what's that, 224, so what's that, 220 nanofarad capacitor on the power input as well. I don't know if this is double-ended, or perhaps the power goes, yeah, I reckon the power goes through it. So you've got lowest impedance, perhaps that's the main power input. Some discs here, I don't know, I'm thinking late 60s myself, but I might be wrong. We've got a set of inductors here. How many connections do they have? They have 3, so I'm guessing possibly the oscillator. You can see the power switches mounted here. Right, let's have a look at the other side. So here's the underside of the unit. So we appear to have 3 inductors which are sealed. They don't stop them moving. They appear to have 3 connections, if I'm seeing correctly. 1, 2, 3. Actually, it could be 4. Yes, I think it might be 4. And then we've got 6 variable capacitors, I'm assuming. This one seems to have lost its adjuster. The 2SA 350 here, and a 2SA 351 here. So I'm guessing that however this is arranged, that maybe 3 inductors are used for one stage with capacitors switched in. On the other side, it's basically an inductor for each band. So, are these the oscillator, or are they the front end? And are these the oscillator or the front end? Good question, I don't know. So I was just thinking, no real direct access to the contacts, because I'd like to give them a clean before I even start to think about powering this up. So, looking at the front, I can't see anywhere, but just thinking, there's a little slot, couple of slots there. I wonder if the plastic part, because it looks like there's a plastic part, which is the slider that's in this metal part, and just wondering if that there's a gap there. I think there might be. Let's see. Yes, so I think that's the entry point there. My fingers are beginning to ache now. Well, the contact cleaner hasn't poured out, so either it's hit the contacts or it's inside a bit of plastic somewhere, not doing any good. So it's one or the other. So looking there, I guess that's the Zener diode. I'm led to believe what I read on Radio Museum, that it's got a 6-volt Zener. And there's a big smoothing capacitor next to it, so I'm guessing there's a dropper resistor here somewhere. Could be any of these, I guess. So when I use it, the only radio I've got is from the 1980s, I believe, so I shall need to be on negative earth and 12 volts for that one. I need to just write down the frequency ranges of these bands, so we can do some tests with a signal generator, I guess. So, do you think it might be a good idea if I actually switched it on? If I had it in the off position, silly boy. Let's see what we've got now. Right. 12, 2.6 and rising. Okay, so we've got an electrolytic reforming. Well, that's looking good, and the supply current's dropped to under 10 milliamps now, so electrolytic's woken up. So medium wave starting at around 520. I'm assuming that it starts at 520, but it might not. It might start at 1000. I don't know. Oh, output frequency 535 1605, but okay, so it's probably going to be 535 above here, so 3.635 probably, I'm guessing. There we go, we've got a local oscillator 3662. Nothing changing, so they must be the RF inputs. I'll switch it over and look at the other side. Well, I'd say that's probably the local oscillator then. Let's just try affecting it. So these are the local oscillator coils then, and they must be the tuned inputs on the other side. I suppose they have to be good to try and stop AM radio going back through it. That's obviously affecting the local oscillator on the 90 metre band, but I wonder if it does others as well. I wonder if you set this inductor at the lowest band. Perhaps these next two are the next two bands up. That will be the next band up, then these two, perhaps, or perhaps these two, and then this inductor for the final one, because you can see that the windings are getting less as you go along, so presumably that's how they've designed it. So yes, you have got adjustment for the local oscillator in every band. It's just done a bit like we would for an oscillator on an medium wave radio. I suppose another interesting thing to note is that as you've got a variable IF, as you tune higher up in the band, your second frequency rejection actually gets better, doesn't it? Because 535 isn't much better than 455 for a second channel rejection, but I guess once you're up to a megahertz it's a lot better. So that's an interesting thought. So that's what I think the adjustments are. Of course, that capacitor with the broken the capacitor with the broken top is a pain to adjust, but yeah, so I guess you just must adjust the inductor at the top band, set of bands, and then go from there. So it splits it, yeah, into 3 sets of adjustments. The Eton, I forgot about this. It's been sitting on a shelf in its box for ages. I bought it from a radio rally. I didn't pay a huge amount of money for it. It seems a nice radio. I didn't realise it had FM stereo. That's how often I've looked at it. I just thought rather than use my little receiver, I'd use this one because it's got a nice large knob to flip round. Well, I've tried doing a conversion. I've plugged the radio into the output on its aerial socket, and I've put a signal in from the signal generator. It's neg 47, which is quite a large signal, and I'm not getting any conversion. So I thought I'd just have a quick look at the voltages. This is in respect to the socket ground, chassis ground, so there's nothing on that pin. 4.7, so let's call that 4.8 on that one, and on that one let's have a look, 5.2, so it's 0.5 of a volt drop somewhere, so something might be happening, although it seems a bit high for a germanium transistor. But let's have a look at this one. So that one's sitting about 5.6. That's sitting near chassis. That's 5.62, 5.65. That's not a lot of difference between the two pins. So we know the oscillator's working because I can hear it. But that's a big difference. It might be because I'm sticking my meter probes in and it's affecting it, but 5.2. I don't suspect for a minute this is a silicon transistor. It's germanium, I guess, if I look in my book. But that does seem 400. It seems a bit high for drop, so makes you wonder whether something's not quite right here. Knowing the lid will affect the inductance, I'm just, as you can see there's a little wire there, I'm just listening to where the local oscillator is. Well, I've been trying to have a look at what the local oscillator is doing with the lid on for each band. And the interesting thing is the local oscillator is sometimes in the middle of the band and sometimes above the band. Now for us to mix, when you mix you get the sum and the difference. Well, the sum's not going to do us any good. If we've got 3 megs plus 3 megs, for instance, it's going to be 6 megs, so that's out of the band of medium wave, so it's going to be the difference. And the only thing I could think of is this example here for the 90 meter band, 3.1 to 4.1. We either have 4.1 plus 525 or 3.1 minus 525 to enable you to tune the entire 1 meg of band, but none of them are what I'd say in the right ballpark, so I'm a little bit puzzled now. Well, I've been doing a little bit of tracing. So the 350 2SA 350 is the mixer. There's an input from these coils, which are just basically your bandpass filters, and they're switched to the base. So yeah, that looks like a normal converter, doesn't it? Then I found out the oscillator coils are connected in series and they drive the emitter. Now when I change band I keep seeing this voltage on this emitter moving around because I guess the local oscillator's a different power, but there's hardly any power flowing through this 100 ohms, so I'm actually wondering if this transistor is duff, because the emitter and the base voltage are very, very similar. It depends what I'm switched to, but I'm just wondering if this transistor's duff. And the only way might be to disconnect this 5 nanofarad, turn the oscillator off so I can see the DC conditions rather than the local oscillator being forced into this emitter resistor here. Okay, so I've disconnected the oscillator input to this mixer. So look at the emitter now. 225 millivolts. 4 volts? Really? Oh, it's touching a case or something. There we go. 364. So actually, that's good. At least the base is 0.1 higher. Collector 596, which it sort of indicates it isn't really conducting. So I've looked the other side where the 100 ohm is, because that's negative. Now let's swap the polarity of the neutron flow. Right, there we go. 22 millivolts across the 100 ohm resistor. It's a very, very small current. Now, before I blame this transistor, I wonder if this 33k biasing resistor has gone high. The 22 might have gone up with it, but it might be there's just not enough base current, maybe. I don't know. I'd expect to be biased on a bit harder than that. I thought, well, blast it, I'll take the transistor out. Let's have a look. Oh, yes, that's good. Yeah, blue, base, red, yep. Not sure I believe 296. Anyway, at least it might be a bit easier to try and measure this 33k resistor now. Oh well. 0.3 to have it switched on. Leakage current, that is exceedingly high. Very high. But that gain is, well, fantasy, I'm sure. This is the 2SA351, which is the oscillator transistor. High 41 seems a little low. I'll have to check that in the book. It's probably within spec though. Base emit's a little high, isn't it? Leakage isn't too bad though, so it's a lot better than the other one. What I decided to do in the finish is fit new transistor in the mixer. I've actually used an AF239. It's a bit of an overkill. It's a UHF transistor, but I've got lots of them, so that's what I decided to use. I've also put an AF239 in the local oscillator. Again, an overkill, but the frequency has come up from what I've seen so far because of the less capacitance, so it's a bit more in the ballpark of where the local oscillators need to be right now. Right, let's just try and get some of this right then. So I've looked at the bands that I need to cover. I'm taking the top frequency and I'm adding 0.535 megahertz on, so then the top part of the band will end up on the bottom of the radio, so that's a bit weird, but there you go. Oh, this moves around a bit. So what I've decided to do is then compare that to what I've got now, which isn't too bad. Now I've got the lids on and I've changed the transistor. There's another AF439 in there, and I found out the frequencies have shifted slightly since I've changed the transistor. So I'll just go through with the original graph that I drew. There we go. And twiggle them and just hope then we might be approximately on frequency. Sort of blob on my... a lot of this peaking here that I saw, very bad waveform, seems to be that it doesn't like the oscilloscope attached to it. So I've got a 1K resistor in series with the scope probe, and that seems to have made the waveform a little bit better than it was at the low frequency end. So it obviously doesn't like me faffing around with it. It's still a bit yuck, but not as yuck as it was. So I'm starting with the 49 meter band on the inductor, and then do the two lower frequency bands, adjusting the capacitors. I'm using the scope as an approximate guide and the radio to get the exact frequency. So it's going to keep putting the lid on, off, on, off. What a pain in the neck. Anyway, an hour of my life has disappeared somewhere doing this. You can see from the figures I've tried to get it as close as I can. It's not easy, especially with those variable capacitors. They're not great, but and of course it's so sensitive on the higher frequency end. So it was quite easy really. You divide it into a set of 3, do the inductor, do the 2 capacitors, work your way up, which is what I've done, and that's what I've ended up with. So it wasn't too bad, but you can bet your life just bending the case. So I'm glad they've all come out slightly higher, so that might stop me going out of band if things adjust themselves. But I'm missing half the screws for this, well about 3/4 of them, so I'm going to have to look to see if I've got any self tappers I can put in it, and hopefully soon we'll get to try it on a car radio. Well, I found something a bit more period. It's a Harry Moss, but unfortunately for the 8-track it looks like the plastic bracket on the head has broken away. It's probably very hard to see, but what would happen if I zoomed in? Oop, too far. Yeah, can you see the crack in the bracket? They seem to all do this, don't they? But anyway, I thought this would be a bit more period. I do like the way that the door is a tuning scale. Obviously it's in meters, but never mind, doesn't matter, does it? So hopefully we should better get some life out of this, and we'll use this. Well, that's my little aerial. I think I'll clip an earth on there from the radiator. Not a very big aerial, but I bet it works well. Car radios are always so sensitive, it seems. Long wave's working quite well.
Or they're based on facts. It's required.
Right. A bit of noise from the ceiling light, but
good evening, Ryan. Come on, Ryan.
T3. Yes, now is Live Nation.
Did she ever tell you this?
right, so medium wave's working, good. Right, let's put that on 90 meters. What's going on there? 60. Oh, some stations there, that's looking promising. 49. 49. Interesting. That's very distorted. Okay, 41, which for some reason won't stay in. Oh, don't put too long a screw in. Back to 49 again. That's distortion is very strange. Right, 31.
Anul trecut, pe fondul creșterii robor.
Interesting, it's very distorted. 19.
El primer tiempo en el estadio Martínez Valero, que está prácticamente lleno. 30.000.
Referitoare la costuri, transport și furnizare. Președintele Asociației Furnizorii.
That sounds very quiet. Okay, and 13 finally. That's interesting, another mixing product. Well, that's quite interesting, the Hitachi shortwave converter. At least we can pick up some stations now, back on the 90-metre band. band there. Yeah, just need to put a BFO in your car radio and well, that's another little interesting project done. Obviously I'm going to have to be careful about the length of screws because I managed to jam the switch, didn't I? So that wasn't so good. I'm suspecting that the problem I had with the mixer was because the transistor's quite leaky, and I'm wondering if it wasn't switching as a mixer properly like it should do. As for the transistor for the oscillator, I think obviously putting a higher frequency transistor in has meant the frequency shifted up a bit, which was in my favour. Something like this, I guess if it was in a vehicle, it's going to vibrate and things are going to go out of alignment, but then it is quite old as well. And as for the lid, I wonder in the factory whether they had a lid with the holes in so they could adjust the trimmers and things for the frequency, because the lid does affect the inductance quite a lot on this. But it's an interesting device, so yeah, I'm glad I managed to get a chance to get it to work. If I waited another 10 years, there might not be any stations to listen to on it, to be honest, but there we go. Anyway, thanks for watching, and I hope you found it of some interest, and I'll see you soon.